The third script I'm going to explain is MyroMovement. MyroMovement contains two enumerations that are used to handle it. There is a move direction enumeration, which can optionally be used to turn the player around. We don't actually have this set up, so I won't go into it. There is a Myro move state, which actually allows Myro to function as a finite state machine whenever there is not a control variant applied. There is normal movement, midair, which is when you're jumping, and then gliding, which is if you hit jump again in the middle of the air. We have a set of variables, where we serialized access to the animator and the controller. This is just for quality of life as a programmer. Having access to these things in this ecosystem of scripts works well. Normally, you want to prevent heavy coupling, but because of the way that these scripts are working together, they are a very tightly coupled system that you just want to keep encapsulated within itself, and you want to avoid coupling it with other systems. I have clicked a button. Let me go back to MyroMovement. Okay, so we do have a Myro control variant, which is an internal movement control variant. Whenever the a control variant takes over, it doesn't always have to take over movement, but if it does, it will call this. And this is referenced in the update and fix update functions, where it will functionally change the way that Myro moves based on whether or not this is null or not. We have a public float with a move speed, rotation speed, jump power, gravity, and glide fall. So in this movement, what we have done is we're not utilizing Unity's default physics, and we just have a default gravity weight, which we can modify the rate at which we fall, but this is applied manually in the fixed update function. Same thing with jump power and the glide fall, etc. We have the move state tracked. This is an enumeration declared up here, but this is used in a switch case statement later. Then we have some internal functions that help choose branches of logic. This is whether or not you've jumped, a move direction that you're moving. This is a vector 3. This a character controller, which is access to our character controller component. And then we have some jump helper floats, which enable us to jump as long as we are within a quarter second of having been on the ground. This is very useful because the physics system and the character controller will sometimes be very touchy, and you won't always remain grounded. Like if you're just running on a downhill slope, it'll sometimes put you in the middle of the air. So this gives a little bit of freedom to fall off, and if as long as you've been in midair for a quarter of a second or less, then you can still jump. This just makes life so much better. And then, as you can see, the unused move direction enumeration. We won't worry about that. So in the start, what we do is we access our controller, our character controller, and we store it, and we use it later on. We have an update and a fixed update function, and these both follow the same paradigm. If we have a control variant, then we will run the movement update variant for the control variant. Otherwise, we check the Myro move state, which is either normal, midair, gliding, or dead. We'll run our normal movement, midair update movement, gliding update, etc. This branches based on where you're at in the running around, jumping, and gliding cycle. And if you're dead, then nothing happens because that's the way it should be. Update functions very much the same, except this involves a lot of different kinds of functionality. Fixed updates operate on physics frames, and all of the movement that interacts with the physics system should be declared during fixed update frames. This just makes the game run a lot smoother. You don't get stuttering. This is where you put certain functionalities. So we have a split in functionalities between update and fixed update because you don't want to put key presses on fixed update because sometimes you miss them. If you use an input get key down function call, then sometimes what will happen is if you're checking for it in fixed update, a regular update will call, and that's when get key down will return true. But fixed update will then call later. And if you're checking on fix update, then by that point, get key down is equal to false. So you sometimes miss frames, and it can be very inconsistent and confusing and frustrating. So you use all of your function calls in update that require key presses, and then you act on them where you actually move the character with the physics system in fixed update. So again, if there's a control variant, it runs it that way, and if it otherwise, it will run normal, midair, and gliding functionalities and do nothing if you're dead. So let's go to our normal movement. As you can see that there is a normal movement update and a normal movement fixed update. So what this does is if the controller is on the ground and it hasn't been a quarter of a second, then this runs and checks just to make sure that you're counting down properly. And then if you press the jump key, which is called in Myro controller, so this is where it actually checks the spacebar, then jumped is equal to true. So that's going to set a Boolean value that will then be checked in the fixed update. So again, you've got functionalities of MyroAnimator, set grounded. If you are grounded, we will set the float timer equal to 0. And if you've jumped, then it gives you move direction and jump power, sets the animator to a jump trigger, and jumps you in midair. If you're just grounded, what it does is it calls get movement vector based on keys, which is a utility function, which functionally is checking forward movement key pressed, backward, strafe right, strafe left, etc. And what it does is it sets a translation value which is stored. So vector 3.forward is +1z, this is -1z, +1x, -1x. What it will do is it will get that whole value, normalize it, meaning if you move one in the x direction and one in the z direction, that would normally, your hypotenuse thing, you'll get a 1.41 vector length, which would give you a 40% run speed boost. So you just set that back to 1, and then you get a move speed. So this way it'll move you in whatever direction your button keys have pressed, and it multiplies it by the move speed. Then, if your movement is not 0, then it sets you to a running or a walking animation. And then it will use this for different kinds of functionalities. We won't worry about that because we don't actually use it right now. But the move direction is set with that functionality. And then we call transform direction, which means we now take that movement and we adjust it to a vector based on the transform. Your actual game object can be rotating around. So what this does is this takes an absolute vector movement and it modifies it to point in a direction based on the local orientation of the direction your character is facing. And then it multiplies it by any move speed modifier you have. By default, it's 1, but if in the case of a charge or something, you might multiply it and set it to 2. Then you rotate from your keyboard presses, which will, if you use A and D, it'll rotate your character. Then it adds the gravity, and then it calls controller.move to actually move the character. This accesses our character controller component, and it then moves it in a way where you can use delta movement, but it plays nice with the physics system. So that's probably the most complicated part. Mid-air update, we're looking if the jump key is pressed, then you set to glide. Otherwise, we apply gravity and rotate. And if you end up grounded, then you go back to normal movement. Applying gravity is set here, where if you're grounded, then do the animator. Otherwise, your move direction minus equals the gravity, and then you move the character that way. Gliding is very similar. You trigger it, you set your move state to gliding, which means in the update and fixed update functions, things will switch. And your Myro animator is set to gliding, and then you continue to move it along with the, so this is your gravity functionality here, where it's just going to steadily make you fall slowly. And then what we also do is make the controller a little bit smaller so that you don't bump into things so easily. You get a smaller hitbox while gliding. So then during the gliding update, if you press jump, you will drop, glide, and fall. This sets your movement back to normal, turns off your gliding animation, and sets your controller height back to normal. And then during the gliding fixed update, it'll make sure your animator is updated properly based on whether you've touched the ground, and you've got a move direction moving you in the direction that you last saved. Or actually, it's moving you in the forward direction. Transform.forward is like vector3.forward, but it points you in the direction that your character is facing and gives you that value plus your move speed. Then it applies your glide fall rate and moves you with controller.move. You can rotate while gliding, and if you touch the ground, it drops your glide function. So we've got a couple of extra functionalities in here. Death and revive. So if you're set to dead, then you stop moving. If you revive, then you can get set back to normal. Those are kind of just syntax functions that have duplicate functionalities. Here you can just set it to normal, which is the same thing as revive. Set your movement state to normal. You can also disable movement, and it just sets you to dead, so nothing happens. You got your get movement vector based on keys and your rotations, which, as you can see, this actually is not working right. We need the Myro controller dot. No, we don't want it called the static. We want it to be lowercase. Myro controller dot turn right. No, this is turn left. And we don't care about that. There we go. So if our left key is pressed or our right turn key is pressed, then our rotation modifier is set to -1 or +1, and then the rotation is set by the rotation speed, and we physically rotate. Lastly, we've got access to control variant functions, which are functions that allow us to access different components related to the movement control, as well as the ability to set and end the control variant status. So, with that whole mouthful said, this is how the MyroMovement functions.